Hello and welcome to this Meridian integration presentation of release management and continuous integration. Meridian integration has implemented this enterprise data management platform across various organizations across Europe, South America, North America, and the Caribbean. Our enterprise data management platform is used to streamline the various facilities of enterprise system management, whether it's a CRM or ERP system. EDMS covers a wide range of systems for data governance, release management, change management, and many other disciplines leveraged by true capability maturity of an organization. For today's presentation, we will be focusing primarily on release management. Release management is probably one of the larger challenges of an organization. Release management is a process by which releases are assembled, deployed, monitored, and verified. However, organizations find challenges with managing releases when they have concurrent support for production as well as many other project deliverables that are competing for those similar resources. EDMS solves this problem by coupling the software configuration management process with the code repository management process and managing that work along with what we call release streams. In this example on the screen, we are demonstrating two streams. In reality, there may be two or more streams. In this example, we are showing two streams just to demonstrate a production path scenario that is competing with a long-lived feature development scenario. What we refer to as a long-lived feature development scenario may be a project upgrade where you're working on your CRM system, where you are already in live production, but you are now in the process of implementing a new version of it. However, as you are implementing the work to perform this upgrade, you still have to support production. In a perfect world, you would be able to do a code freeze and lock down any changes to production while your project is underway. However, in reality, that is not the case. New discoveries, changing business requirements that exist within the production realm mandate changes and full support for that production stream. EDMS solves this problem by managing and implementing a concept known as release streams. A release stream takes a feature or bug fix from inception and manages it across the environments. A feature, which some may refer to as an enhancement, or bug fix, that some may refer to as a defect, is basically a compilation of artifacts used to alter or enhance the behavior of the enterprise system. What are those features? What are the artifacts? They fall into two different categories. Data configuration, which originates or resides within a database somewhere, and code repository, which contains source code used to implement that particular feature. So in this particular regard, we have a configuration database set up for our production support stream, as well as a repository branch that is set up for our production support stream. Likewise, we have a Project X configuration environment, which contains the configuration required for this project or this long-lived feature development lifecycle. EDMS implements a process by which those changes could easily be compared, merged, and validated between streams in order to make sure that work is properly allocated and concurrency is not a challenge. This improves the overall quality, the overall reliability, and minimizes the work associated with competing streams. We will now demonstrate EDMS capability in terms of implementing these industry standard features and concepts. These features and these concepts are widely accepted by the industry with regards to code management, check-ins, check-outs, merging, and things of that nature. We've taken all of that industry knowledge and domain expertise that we've acquired over the past couple of decades, working with very large organizations, implementing various ERP and CRM platforms, that we are able to take that experience and incorporate it within our Enterprise Data Management Suite platform. So the beauty of this is that EDMS takes all of these complex disciplines and manifests it within our software as a single click of a button in order to facilitate these otherwise complex features. Within Meridian EDMS, we will start the dashboard. those artifacts that we referred to earlier as source code and configuration, those exist inside of packages. Those packages are then combined to create a release, and then the release manager will then perform his or her job of coordinating and deploying those releases to the various environments. In this particular case, I will start to demonstrate how a feature is introduced into the work stream. I will start by creating a package. I will give the package an ID and a description. I will say CI for the functional area, customer information, account for the subsystem, and I will give the feature or defect number. In this case, let's do a feature, and let's give it version 1. This is a naming convention. It could be anything, but this is what we recommend to keep your packages organized. In this particular case, here I would choose a configuration package, and here I will actually put in the hashtag of this package so that I can marry up my code and my configuration. I will put the hashtag in front of here, and I will explain that shortly. So, EDMS is the only platform that combines configuration with source code. In this particular example, I'll take an extraction of my configuration. I'll take it from the database. I'm taking the algorithm that is required for that feature, and I will choose the algorithm that is required. Now that I have selected this algorithm, with the click of a single button, I can extract all of the required data for that configuration. So without writing a single line of SQL, I am able to extract all of the required data without requiring any type of complex understanding of the data model. EDMS has the ability to extract the data required for your particular feature. EDMS also couples this with the source code as well. In this case, we do not have any source code staged. The purpose of the hashtag is that we tag our package so that the continuous integration process will marry up our source code with our configuration. By having this package here, we can come over here and attempt to do a manual code sync. In this case, we would not pull anything because we have not staged anything, but I wanted to demonstrate this. In reality, you wait for the code migration and continuous integration process to occur. So in this case, how do I introduce my source code into the work stream? EDMS pulls artifacts in the previous slide from the configuration database and the source code from a source code repo branch. This is defined in EDMS as a source code repository. That source code repository could be SVN, Git, it could be any industry-leading source code repository that EDMS will monitor periodically. In this example, we're telling it every 60 seconds for the purposes of demonstration. In reality, it may be something less frequent. Now, once the source code is identified and we pull it for automatic checkouts, we also extract data from environment definitions. So our environment definitions define the configuration data, where our source code repositories define our code repos. A source code repository is also paired with a build environment, so that when the build environment has detected that the packages were automatically created as part of the continuous integration process, it will generate an automated system release and put the packages in it. And those releases will automatically deploy to an integrated shakeout environment, and we have that polling set up for every 5 minutes. In reality, that may be every hour or nightly. In this particular case here, let's go back to my package. My package only contains configuration, so how do I introduce my code? I introduce my code by going into my project and setting up a new algorithm. In this case, I am developing a new algorithm, and I will say DevOps with EDMS. I will save that, and now I'm done with my development. And as a developer, I would like to commit those changes. Because I am done with my changes, and I would now like to commit those changes, I can put in any description, EDMS tag, and I can commit those changes to my repo. Now, as a developer, I'm done with my work. So in order to introduce this into my integration stream, I will check out my integration stream, and then I will merge my local work into that integration stream. This works with any repository software, whether it's Subversion or Git or Team Foundation Server or anything like that. So in this case, I now committed those changes and I will push them up to my repo. Going back to my earlier point, we have a source code repository set up to monitor such activity. It will poll at every 60 seconds, and it will look for such commits that are performed against that particular branch. In doing so, it will automatically associate any code with my configuration. In this case, we're waiting for that polling process to complete. It runs every 60 seconds. And once again, EDMS is very unique because it couples the code and configuration process, delivering a unified processing standard for comprehensive release management strategy. So at this point in time, our continuous integration process has now associated the code with this configuration. If I click on this code, you can actually see that it has automatically picked up DevOps with EDMS. Now that the package has automatically been paired up, again, the source code repository has swept that change into my package. It is also associated with the build environment. The purpose of the build environment is to take all of those packages that have been staged by various developers and automatically put them into a release. If a package has not been staged by a developer, then the system will create a package automatically to contain the source code. But the purpose of staging a package in advance is so that you can go ahead and stage your configuration so that your configuration waits for your code to come in. And once that code comes in, they go together. So in this case here, our continuous integration process is set up to run every 5 minutes. It will take our package and automatically associate it with a release. So let's give that a moment. Here we go. Continuous integration has automatically created this CI release. This release now contains the package that was previously staged. If multiple developers were staging packages or were working on features, all of those features would be listed here. In this demonstration, we only have one, so there's one feature contained in this release. So once this release has automatically been created, the features are swept into it. The system will now communicate with the build server in order to request a build image representative of those incremental changes. Keep in mind that these features represent incremental changes. So the incremental changes combined with the pristine baseline will be used to request a build unit from the build server. A build unit is basically an installation program that can be used to migrate to other environments so that those features are compiled and installed. EDMS allows developers, as they are developing these features, to have continuous integration automatically detect those features and migrate them into an integrated environment. The beauty of that approach is that the functionality of those features are validated outside of the developer's environment. In many cases, features work fine on the developer's environment because they have all of the dependency properties staged. However, an integration environment gives many benefits. One of those benefits is that it validates that feature outside of the developer's environment for the very first time. It does automatic shakeout in order to verify that this build does not break the system. So as part of that continuous loop, the release manager will then be able to select those authorized releases for subsequent migration. In this case here, we've requested a build from the build server, and now that build has come back to us. So this binary unit that is associated with our release, it's a physical installation package program that gets deployed to subsequent environments. So now the system is automatically migrating that installation into our continuous shakeout environment. How does that work? I will take you back to our source code repository. If I go to the integration stream, and if I see that there is a build server under the continuous integration settings, the release is automatically created under this specified stream. Once the release is created and the code build is generated, it will automatically migrate it into the CI target. That is where we do our continuous integration work. And if I go back to our previous slide, this line here represents continuous integration. So as developers are developing features and bug fixes, we're automatically deploying them into the integration environment. Once they are verified there, the release manager will then migrate to QA, and then the testing coordinator would verify QA, and if it's successful in QA, then we migrate to UAT and ultimately production. So this is where the release manager does the migration. However, in these first preliminary environments, we have our continuous integration feedback loop. This continuous loop that is constantly introducing and shaking out those changes, and that is exactly what we've seen here. So what I will do now is I will go into the environment where this has automatically been migrated. Once the migration is done, let's go to our Release Manager dashboard. Let's go to our integration system, and let's go to the release that we have here, the one that was automatically created. We see that the code build was generated, and if we look at our log, we can see that the automatic deployment was automatically completed. So at this point in time, we will log into our CIS system and we will verify that those features are there as part of a successful automatic migration. We can log into the CRM system. In this case, we are using Oracle Customer Care and Billing as our example. We can log into that CRM system and verify that functionality. I will bring up an account. The functionality that we implemented is an alert for each account, and that alert basically says DevOps with EDMS. So if I come over here into the CRM system, there it is, DevOps with EDMS. That is how easy it is for a developer to take their features and introduce them into the integration stream, to where they can do their end-to-end process verification. Once that process is done and verified, the release manager, in close coordination with the testing coordinator, can come over here and mark this package as verified. Once that package is verified, it can be used in subsequent processes. But say if we did not verify this package, let's not verify it. So this release stream here is not verified as of yet. If I go back to my release manager and I look at my various work streams, and if I look at my support stream, I see that my support stream has a successor stream, which is QA. So QA follows integration. So that means that QA cannot receive work or releases that have not gone through integration. So integration must be the predecessor of QA. So in fact, QA is the successor. You can see this visually here as well. You can see here that for our support stream, that QA is a successor for integration, and UAT is a successor for QA. And production is a successor for both support UAT and upgrade UAT. And the list goes on. There's an unlimited number of release streams. Let's go back over to our release. Now I have not verified this release as of yet. However, I will demonstrate if I were to copy this release, and I would give it a different name, support QA, and I'm picking up on a previous release that has already been deployed, and that can be the old release name. I would make up a number here. Now that this release has been saved, we want to associate it with the QA stream. If I click Save and attempt to deploy, I get various items that may show up here. So in this case, I have chosen my production support stream, and it gives me a message. All packages in this release must be marked as verified in the predecessor workstream, support integration for external package ID. So it gives me that message. It basically shows up as a warning so that the release manager knows that in order to do a migration for the QA stream, we must first go back to the integration stream and verify. So inside of our integration stream, let's go ahead and verify. So in this case, I have verified this release. And now if I go back to my QA stream and I go to that release that we have staged, I can see that the warning has gone away and I can now proceed with the process of doing that work. I would like to demonstrate one last point on that topic. Let's go back to our integration stream. You can see that it shows up as green, which means that it has been verified. However, since we have not done a subsequent release, or whatever the case may be, I can go to a previous version and revert that change. So, for example, if I go back into my CIS system, it says DevOps with EDMS, but I don't want that anymore. I want to go back to the previous version. So for this integrated environment, I can go back into my release manager and take the last release that we've used here. And because a release is full comprehensive, you can always reset an environment back to that precise release level. So in this particular case here, I can just simply redeploy this release back into the integration stream in order to back out that particular change. And if I process that deployment, that will in fact back out this change inside of the target environment. It's that easy to do backouts. Well, that concludes the release management high-level overview in terms of how you start with packages and how you take those packages and how you can incorporate features within those packages. I've also demonstrated how the continuous integration process will automatically associate those packages with releases and as a result request a code bill. So in the spirit of stream management, going back to our slide here, just to tie it all back together, we've demonstrated how source code is managing our repository. We've also demonstrated how configuration is managing our databases. Using EDMS, we were able to combine those various features and artifacts to what we refer to as a feature. Using continuous integration, EDMS automatically migrated that feature into this integrated environment. We then verified that the integrated environment was successful with that feature. Upon verifying that feature, the release manager would then be able to take those verified integrated releases and create requests for QA migrations and UAT migrations. We've also demonstrated how you would back out a particular feature by going to the last known release that you would like to revert back to. It is that easy to do. EDMS makes it simple. And that concludes the very high-level overview. If you're interested in learning more about our comprehensive release management strategy across any CRM or ERP system, please contact us at sales@meridianintegration.com. Again, that is sales@meridian-integration.com. Thank you.